All right, we're going to talk about advanced factoring in this video. I know we've done it at the beginning of the semester, but we want to go over it because we're going to need it pretty heavily for this unit. And I do want to talk a little bit about the worked example because there are some numbers that pop up here that you might be going, where did they come from? So this is your initial trinomial here. And this is often called the AC method for factoring because you're going to take your A value of 2 times your C value of 10. So let me go ahead and mark that. That's the AC. And the product of A and C in this case is 20. So I want you to tell me two numbers that multiply to 20 and add up to 9. Now, you can always go through and write out the things that multiply to 20. Let's see, 3 doesn't go in there, so 4 times 5, and that's all of them. Well, lo and behold, 4 times 5 is 20, and 4 plus 5 makes 9. So now using these two numbers, we literally split this middle term. So instead of 9x, you create two terms, a 5x and a 4x, and then you do exactly what we did in the last video with factor by grouping. So group the first two together, get a GCF of x, group the second two together, they have a GCF of 2. So the two parentheses sets are identical, so that becomes one factor. The other factor is what's left over of x plus 2. All right. Now, if you have been in my class, you'll notice for me, I tend to just use guess and check. So if you can guess and check with these problems, go for it. Advanced factoring in the AC method is just sometimes helpful if the numbers get a little bit bigger than you want to try to play with, but it's up to you. So I'm going to show the examples using factor by grouping, which would be the AC method. So let's see. A is 3, C is 8, so AC would be 3 times 8 is 24. All right, so what multiplies to 24? Well, 1 times 24, and I'm actually going to stop right there because, well, I already know that's what's going to get me 25. So I don't need to look any further in this problem to see what could work. So I'm going to take my first term, leave it as 3x squared. I'm going to split the middle term. Instead of writing 25x, I'm going to use 1 and 24. So plus 1x plus 24x. It doesn't matter what order you write them in, so understand that either way could work. And then your last term stays the same. Now that we've got it as a 4-term polynomial, this is just like factor by grouping. So I'm going to group the first two together. They have a common factor of an x. So I'm going to take that x out. So 3x plus 1. If I group the second two terms together, they have a common factor of 8. So that would be 3x plus 1. Do a quick check. 3x plus 1 matches 3x plus 1. So that becomes one of my factors. The other factor is the two GCFs, x plus 8. And that is the factored form of that problem. So let's move on and take a look at the next one. Again, you could be absolutely doing these with guess and check, and then just check your answer at the end because obviously your work would look significantly different. All right, we're going to take A times C. So A times C is going to get me negative 14. So 1 times 14, 2 times 7, that's really all that works. Now, to make a negative 14, one of the two numbers in the pair is going to have to be negative. So if I look at negative 5 here, 1 and 14 are not going to get me a negative 5 no matter which one of those I make negative. But 2 and 7, if I make the 7 negative and leave the 2 positive, that would be the pair that would work. So let's go ahead and do the rewrite. So 2x squared. Now, again, order won't matter here, so I'm just going to go ahead and use the order that's written. So plus 2x minus 7x and then minus 7. Group them. All right, what do the first two terms have in common? Well, they have a 2x in common. So leave behind x plus 1. Second two terms both have a negative 7 in common, leaving behind x plus 1. So x plus 1 and x plus 1 match. Factor that out, and then what's left would be 2x here and then minus 7. And that is the factored form for that second problem. All right, I'm going to keep moving on here. Next one. Now, for this one, before I go into factor by grouping or AC method or anything, I actually noticed that there is a common factor across all three of these terms. So all three of these terms can be divided by 2. And I would highly recommend you do that because that's going to make the numbers just that much smaller to work with when you're trying to solve this. Now I'm going to go ahead and do the AC method, or again, you could do factor or guess and check on this. So let's see, I'm going to take my A value here of 3, my C value here is negative 2, so AC is going to be negative 6. So 1 times 6 and 2 times 3 are the only thing that work. And I need to multiply to a negative 6, which means one of these two numbers needs to be negative, not both. All right. So no matter what I do with a 2 and a 3, if one of them is negative, there's no way I'm making a 5, positive or negative 5. So I'm going to go ahead and use negative 1 with positive 6. So there's going to be 2, and then I'm going to go ahead and split this up. So 3x squared minus 1x plus 6x minus 2. Now be careful because we're going to have some extra sets of parentheses and just some weird things going on. So if you need to color code, color code. And you'll notice that the 2 that was out front here, this very first GCF I took out, it's not going anywhere, right? It's going to keep becoming part of this problem until the end. So there's my 2. Now, what do these first two terms have in common? And actually, I'm going to take this and make this a bracket just to make it easier for myself. So those first two terms, they have an x in common, and that's it. All right, so let's see, 3x minus 1. What do the second two terms have in common? They have a 2, so positive 2. So 3x minus 1. And then I'll go ahead and use the bracket over here to close it all up. All right, so let's see. 3x minus 1, 3x minus 1 matches. So we're going to have the 2 out front, a factor of 3x minus 1, and then the leftovers of x plus 2. So lots of stuff going on with this one. Just be careful that you don't lose any part of it. Now, if you wanted to, write down this 2 and then temporarily forget about it as you work through your steps of advanced factoring and then make sure you put it at the end, that can work, okay? Just be careful you don't lose it along the way. All right, we've got some more problems here for practice. I am just going to do the odd problems. The even ones will be in the answer key, so you can check on those and let me know if you have any questions. All right, so A times C is negative 49. So 1 times 49 and 7 times 7 is the only way that's going to work. And out of these two pairs, the only way we're going to get any form of a 48 is, let's see, if I make negative 49 and do positive 1. So 7x squared plus 1x minus 49. Whoops, that's a 9. 9x minus 7. All right, group the first two, take out an x, 7x plus 1. Group the second two, they have a negative 7 in common, so 7x plus 1. 7x, those match. So 7x plus 1, and then x minus 7. Okay. All right, number 5, try again. Number 11, so 5 here is my A value, negative 4 is my C value, so AC is going to be negative 20. 1 times 20, 2 times 10, 4 times 5 are all the possibilities. And out of those possibilities, the only way we're going to make a 19 is with a 1 and a 20. In fact, I'm going to make the 1 negative and the 20 positive. So 5x squared minus 1x plus 20x minus 4. So that creates the 4-term polynomial that we can now group. So let's group up the first two. They share an x, 5x minus 1. I'm going to group up the second two. They share a positive 4. So 5x minus 1. My two sets of parentheses match. So 5x minus 1 and then x plus 4. There we go. All right, number 13, which I think is the last one. It is. All right, and again, I'll have the even numbers done in the answer key, and of course, you can ask any questions that you need to. All right, 50, 260, and 50 are all divisible by 10. So I'm going to go ahead and take a 10 out of all of these terms. So 5x squared minus 26x plus 5. Now I can look at doing the AC method. So A and C, that's going to get me 25 when I multiply them together. So 1 times 25 and 5 times 5 are the only possibilities. So the only way I can make a 26 is using 1 and 25. Now I need a positive 25 when I multiply and a negative 26 when I add. So both of these need to be negative. Okay, a negative times a negative is a positive, so that'll work. So this is the pair I'm going to work with. So 10, and then I've got 5x squared minus 1x minus 25x plus 5. All right. Now this might be a place where you'd look at it and say, I'm going to go ahead and just, skip that 10 to the end. And if you wanted to do that, there we go. There's the 10 at the end. All right. And so now I'm just going to focus on the this 4-term polynomial here. So I'm going to group these first two. They have an x in common. So 5x minus 1. I'm going to group the next two together. And this is where, again, I want to be careful to match my signs. So this first part started with a positive. This is a negative, so I'm going to actually divide out a negative 5 from both terms. Okay, and that would get me 5x minus 1. So now these match. Okay, and so to put it together with my answer, I'll go ahead and use that orange again. So 5x minus 1 is what matched between them. And then we've got x minus 5 for the GCF from the first one and the GCF from the second one. And that gives us our factored form. All right, so this is a lot of practice with just the AC method. Again, if you wanted to do this as guess and check to your heart's content. It will absolutely work for these problems. Sometimes students just like having the steps to do AC method so they're not having to fight through the guess and check. Up to you.